Hi, my name is Sean O'Kane with ChipEstimate.com and ChipEstimate TV, your IP resource for your next chip design in the world of the EDA industry. My guest today is Michael Dimelow, Marketing Director at ARM. Thank you very much for joining us today.
Thank you very much, Sean.
ARM is well represented here at DAC in San Diego.
Yep.
And you'll be presenting in our booth today and tomorrow or throughout the week.
Throughout the week, yeah.
That's right. And really focused on the AMBA products.
Correct.
Okay. And we wanted to find out a little bit about the AMBA 4 and in regards to the power initiatives that ARM has.
Yep.
In regards to the AMBA 4, how does that help the power consumption that's challenges that these designers are seeing in their designs, their modern designs?
Okay, so I'm going to draw a distinction here between the specification, which is AMBA, and product implementations that we do and then our partners in the market do. So AMBA 4 is the fourth generation of the AMBA specification.
Right.
Yep. It's a public document as of today. And what we've done is we've split AMBA 4 into two phases. Last year was phase 1, strangely, and this year is phase 2. And in phase 2 we're introducing 3 computer science techniques: coherency, memory barriers, and distributed virtual memory. And coherency is one of the most important things for managing off-chip traffic, which then links back to power consumption, in particular when you're maintaining coherency between CPU and CPU clusters, and between I/O masters such as graphics processors, our Mali T604 graphics processor, and the processor caches, where you're trying to access shared data structures that exist in the CPU caches. The GPU snoops into the caches, and it's able to avoid going off chip for those data structures, and it's able to process them and push them to screen or whatever it's going to do next. Yeah. So AMBA 4 is a spec that defines the interfaces between the processor and those I/O masters such as graphics, and it defines a protocol for talking across your interconnect. The implementation in the interconnect can be done by ARM, and we've got our own family of interconnects and memory controllers, or it could be done by other partners in the market that build similar technologies. But the specification itself is really geared around introducing new techniques for managing coherency and managing and minimizing traffic going to external memory wherever possible, which in turn raises performance and reduces power.
Perfect.
Yeah.
Excellent.
Yeah.
So what ARM processors support this bus interface?
Okay, so in the CPU world, the Cortex-A15 supports AMBA 4 ACE, which is the coherency extensions that we've announced this week in the AMBA 4 spec. And the GPU, the Mali T604, the latest graphics processing engine, that supports ACE Lite, which is a subset of ACE. And with ACE, we've gone from a certain number of channels, and we've expanded that by 3 channels. So the big change between the previous spec, AMBA 3, and the introduction of the coherency extensions is the addition of 3 channels. So that's what we've done. And the reason we've done that is to introduce coherency to minimize that off-chip traffic.
That's perfect. So we're going to be putting this interview up on ChipEstimate.com. We'll deliver it to ARM, as well as we'll tweet this out. I really appreciate you spending a little time with us during your very, very busy schedule here at DAC.
Yep, thank you.
2011 in San Diego, California. So I look forward to see your presentation on our stage later on.
4 o'clock tomorrow. 4 o'clock.
That's right. Okay. Thank you, Michael.
Cheers.
All right.